Okay.
Anyone not here?
William, question? Yeah, what's the first type of number?
Natural or counting.
Good, natural or counting. We're going to call it N. So it's an abbreviation. Hopefully you know that stands for natural. And that starts with what numbers? Raise your hand if you know. Sam?
1.
1, 2, 3, 4, 5. That's naturally how you count. The second set of numbers was called the what? Raise your hand. Yes, ma'am?
Whole numbers?
Whole numbers. And what kind of numbers were the whole numbers? Yep, Drew?
0, 1, 2, 3.
0, 1, 2, 3, 4, 5. So what's the difference between the wholes and the naturals? It's one number and it's the number 0. So can I ask you this? How many numbers in the natural category? How many natural numbers are there? One? Infinite, yeah, infinite. How many numbers are in the whole category? Yes? Infinite. Now I'm going to ask you a deep question and see if you guys can get it. They both have an infinite number of numbers, right? Which one has more? Wait, whole.
They have the same.
Okay, these are the two answers I'm hearing. They have the same amount, right? They're both infinite. Or the wholes?
No.
The answer is the wholes. Because they have one extra number more than the naturals, and it's 0. That's why we draw that bubble a little bit bigger. Obviously, it's not that much
Basically,
bigger.
it's not infinite all of them, it's infinite up. Like from the first
Yeah, there's infinite negative, which we'll get into the next category. But yeah, there's still an infinite number. But yeah, negative infinity, that changes things up. The third group. Yes, sir, Hudson?
integers.
Integers, yes. Now, naturally you would think, well, what letter should I use?
Z.
Oh, yes. Because you guys paid attention. Not I, but Z. And Z stands for, raise your hand if you know. Raise your hand. Yep, Jackson. Number in German. Zahlen. And again, the German language is a stronger guttural sounding language. Zahlen. Why? Because they came up with a lot of what we do with integers. And then the most important category that we looked at, let me give you a hint. It's up there. Yes?
Rational numbers.
Rational numbers. Now, you would naturally think R, but it's not R.
Oh,
It is Q.
Q. Why is it Q?
What a great question. Why Q? Well, if I just said integers were Z, was represented by the letter Z, wouldn't it be kind of like why? But then I gave you the reason why, right? Zahlen, German word. Q. Let me see what language it was. Oh, it's English. Q. Okay, let me review what Q is, rational numbers, and then maybe you guys can come up with it. Okay, can anyone tell me what the definition of a rational number is? And here's a little help. What's a rational number using your definition? Okay, yeah, Brad?
Like fractions and decimals?
Okay, fractions and decimals can be rationals, but what's that like long definition maybe summarize? It has to do with fractions. Okay, Philip?
Numbers that can be written in the form of A over B, where A and B are both integers and B does not equal 0.
That's correct. You guys get that? So it's a number that can be written as a fraction A over B. A and B are both integers, and B does not equal 0. Okay. All right, does anyone know what that Q word is yet?
Rational.
You know, Mary?
Oh, no.
Okay, let me give you another hint. What kind of bar is that? Raise your hand if you know. What kind of bar is that? What do we call it? Grace?
No, I think
Okay. Oh, you think you know? Okay, let me see. Do you want to guess?
Is it quotient or no?
Okay, wait, quotient, doesn't that have to do with what operation? Division. What? You are correct. It's quotient, but that's division. I'm talking about fractions. This is called a fraction bar or a quotient or a division bar. Isn't this division? So isn't A over B, which is a fraction, also known as a divided by b.
Yes.
So that's why we call it a quotient. And you're still maybe thinking to yourself, why don't we call it f for fraction? Actually, that's a very good question. I don't know why. Oh, I do know why. This is going to help us to understand how I can make these numbers into different types of numbers. Okay, so keep that thought. What is this? A fraction, and it's what kind of problem?
Division.
Division. Okay, just remember that. Okay, any questions on these type of categories? This is a review. You guys okay with that? This is kind of cool though, guys, really. Because on your homework, remember how you had to tell me, is it natural, is it whole, is it integer, is it rational? Okay, here's a big hint. Give me a natural number. Yeah, say it. Any natural. 5? 5. Is that a natural number?
Yes.
It's also a,
Whole.
which is also a,
Integer.
which is also a.
Rational.
So if a number was natural, you could have just put whole, integer, rational. You're done. Give me an integer. Someone give me an integer, a negative integer. So we know what we're talking about. When?
-6.
-6. So -6 is an integer. It automatically is also a rational number. Is it a whole number?
No.
No. Is it natural? No. So you see how the bubbles kind of help us to understand what kind of number that is? So did anyone use that as help for your homework?
Yes.
Okay, good. That's why we did the diagram. That's division, also fraction. Why does that matter? Okay, let's do a little chart. And you guys are going to reproduce this here. You don't have to put an ending yet because you might write long. Okay, we're going to have 2 rows though. We're going to have the Q row. Q stands for what type of number? Rational number. So we're talking about the rational numbers. And then this one right here, the second row, is going to be A over B. What we're going to do in this little chart to help you out is to figure if this is a rational number, doesn't that mean it can be written as a fraction? Isn't that what the definition says? If this number is rational, it can be written as a fraction. So let's start off with this first number right here. -7. Okay. -7 is what type of number? What's the smallest bubble it goes into? What's the smallest bubble it goes into, William?
Integer.
Integer, which means it's also a
Rational.
rational. So it is rational, but that means this can be written like that, and that
Not true.
is not computing with me, or does it? Does anyone know how to write this as a fraction? Mary? -7 over 1 is correct. -7 over 1. Now, I mean, that's the answer, but like maybe some of us are thinking, how? Do you remember how I called this a division problem? You guys remember I called this a division problem? All right, what's -7 divided by 1? Yes, ma'am?
-7.
So are these the same?
Yes.
They are. So we're not making that up. In fact, hint, on your homework, if you have an integer, so if you can identify that number as an integer, that is an integer. You know how to write it as a fraction? You just write that integer over 1. I want to see how many of you remember that, because I'm going to ask that same kind of question and see who is paying attention. All right. Next group, we're going to have 2.5, which is a mixed number. So is 2.5 a natural number?
No.
Whole number?
No.
Integer?
Yes.
Ooh.
Yes.
Pause.
Yes.
An integer is what kind of number? Raise your hand. Tell me what the definition of an integer is. What's an integer? Got theirs?
A number that can be a negative, like equivalent of negative.
Close, but we have to be very specific, because then we can say, well, what about this and what about that? Very specific. Yes, sir.
A whole number and its opposites.
Okay, it's any whole number, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and its opposite, -1, -2, -3, -4. So does 2.5 fit in that?
No.
So 2.5 is not an integer. Okay, so it's not an integer. Is it a rational number?
Yes.
So you're saying it can be written as a fraction. How would you write it as a fraction? Yes, Grace?
5/2.
5 over 2 is correct. Does everyone, okay, how about this? Who remembers how to go from here to here? Not everyone should raise their hand, it's okay, because we're going to go over this process. All right, 2.5 can become 5 halves. This right here is a rational number, therefore that is. Okay, we'll go through that process. That's one of the main parts of your homework. Okay, next one. Favorite type of number, decimal. And then their faces fell. On your about me's, one of the main things I saw were decimals and fractions. I hate them. I don't like them. Don't know how to use them. Please help me. And so my goal is to help you out. Okay, 2.5 or 2 5/10. Is that a natural number?
No.
No. Whole number?
No.
Integer?
No.
Good. No, it's not. Rational?
Yes.
Okay. How do I write that as a? How do I write it as a?
Oh.
Drew?
You put it into a mixed number, and it would be 2 5/10, and then you reduce it to 2.5, and then it makes up 5 halves.
Okay, nice, good. If you didn't follow that, that's okay.
That's
Very good
complicated,
process.
Drew.
So, whoa. Oh, I'm so sorry. 2.5 is 2.5, so they should be the same rational number? Okay, good. So we get that. And we'll go over this process again because I want to make sure you guys get it. Let's go with another number, and let's see if you guys can identify what type of number 0 is. What's the smallest bubble it fits into? Whole. Therefore, it has to be in
Integer.
and then therefore it has to be
Rational.
okay. So somebody give me that form.
It'd be 0.
Well, raise your hand. Michelle, yeah.
0 over 1.
0 over 1. Wait. I thought integers can be written as that integer over 1. Well, is 0 an integer?
Yes.
So I can write it just like that. Can you also write it any other way? It's kind of a tricky one, Hudson.
Can it be like 0 over 0?
Okay, great question. 0 over 0, I wish I had time, Hudson, is actually everything and anything, and I don't know which one. Your calculator is going to say indeterminate. That means it can't determine what the answer is. So no, we don't want to say that because that's a special number. Now that's great, Hudson, because a lot of people are going to get 0 over 0 and say, what does that equal? 0. No, it doesn't. It equals everything and nothing but something. Okay, let's not get too bogged down. 0 over 1. Can you say 0 over 10?
No.
Yeah.
Yeah, it's still 0. Can you say 0 over 7?
Yes.
Because with 0 parts out of 7, it's still 0. So you can say any denominator, but this is the easiest way to remember it. Okay, last number here. Uh-oh. Oops. Wait, did I mean it? Yes, I went to the
I
right now.
know.
Okay.
Can I take a guess?
On the count of 3. So I'm going to count 1, 2, 3. Then you give the answer, okay? You can just say it if you know it. If you don't know it, just sit there quietly and listen. 1, 2, 3.
1/3.
1/3.
Okay, I heard it. 1/3.
Yeah.
All right. That's a bit unnatural, it seems like, right? It's like, what are you talking about? You had one of these problems in your homework. Do you guys remember? And I gave you the answer.
Yeah,
Yes.
So thankfully that happened. But some of you may be questioning, no. That's not possible. So let's work backwards and see if we can figure it out. So can I do this? Is this a division problem?
Yep.
Okay. So the division problem would be 1 divided by 3, correct? 1 divided by 3. By the way, listen carefully. Whenever you're changing this into a decimal, which is what we're going to do, you have to put the numerator inside this box, the denominator outside this box, no matter what number it is. But Mr. A, what if it was 3 over 1? Don't you switch it around? No, you put 3 and 1. Okay, no matter what. In the box, outside the box, every time. All right. So you know 3 is not going to go into 1, right? but you add your decimal point and a few zeros, bring up that decimal. So you guys remember this little process?
Yep.
Does 3 go into 1? We said no, it doesn't. Does 3 go into 10?
Yes.
Yes.
3.
3 times 3 is
9.
9. Subtract, we got our 1, bring down a 0. 3 goes into 10? Oh yeah, 3
so
times.
3 repeating.
Have you ever had deja vu? Like, I guess Mr. Newer or Mr. Josh said, that's deja vu. It feels like I've done this before. But let's keep going. 3 times 3 is 9.
9.
Yeah, I know this answer. All right. What are you going to notice about this answer here, this quotient? Yeah. Well.
It'll just keep repeating with 3.
Oh, so when you get this,
Yeah.
there you go. See? Okay, now listen to me carefully. You don't have to know what all these are in fractional form. That's Algebra 1, Algebra 2 stuff. So you should be able to go from 1/3 into this format, like divide. Can you guys do that? Okay, we'll have practice with that today. So don't worry, like, Mr. Ray, but I didn't know that. It's okay, some people memorize it. Some people have no clue. That's okay, yeah.
Wouldn't 6.6 be 2/3 and 9.9? Well, no. But 6.6 is 2/3.
6 repeating, 0.6 repeating, 2/3, and 0.9 repeating
Would be
is,
1.
and see, here's the, 0.9 repeating is not 3/3, right?
Yeah.
But it's very close. Let's not get into that, but yeah, it's that pattern. Okay,
Is it like 3 out of 3.1?
something like that, yeah. 3.111, it's like 3.0000001 out of 3.00002. So close, so close. Yep. Okay. This is what I want to focus on right here, guys, right here. If you don't know how to go from 2.5 to 5/2, we're going to practice it. And this is something that I want to make sure you guys get. Listen to me carefully. Do I like shortcuts? Of course I do. I tried it when I drive from here to home. I want to take shortcuts. I do not want to go the long way. But in math, it's good to know shortcuts, but the reason why you can take this shortcut. If you don't know how to why you take that shortcut, you don't know what you're trying to avoid or trying to prevent, whatever the case is. So here's what we're going to do. Let's take this number 2.5, like we did before, and let's turn it into an improper fraction, or A over B form. Okay, ready, guys? Do you know what a mixed number is? Okay, what is it?
A number that's mixed?
Naturally, yes. Now?
It's one whole number and a fraction.
Okay, you just said it, and I'm going to use her words there. Read this number with me. 2 and 1/2. Can you guys say that?
2 and 1/2.
And Natalie just said, and I hope some of you understand this too, that means there's a whole number part and a fractional part. Is that okay to say, or am I making stuff up? Okay. That means there's a whole number part and a fractional part, right? There are two parts, and they're combined. Is combining addition?
Yep.
Okay. So let's see. 2 wholes and a half make 2.5?
Yep.
Yeah.
Okay, so I'm not making stuff up. I don't want to make stuff and I'm like, no, that's not true. It is true. Okay. I did this with the last class, and some of them were looking at me. And did I talk to you guys about when you might get upset at me about stuff? Did I talk to you guys? Okay. In pre-algebra and even algebra 1, there are things I present, and you look at me and say, no. No. You just think to yourself, no, I hate that. And I might not like you so much. So that's what you're saying to me, because what I put up here. My goal is to help you guys understand what numbers are, because then when you get to these hard concepts later on, you're going to be like, that is tough, but oh yeah, it's because of this last year or this last month. Okay, so you guys are okay with that. I want to change this into a fraction. We already know what the answer is, by the way, right? It's 5/2?
Yep.
Okay, let's see if we can get it this long way. Okay, are you guys okay with me saying that 2 can be a fraction 2 over 1?
Yes.
We talked about that, and hopefully it's not too brand new. All right, plus 1/2. So same problem, just written a little bit differently. can I just add these fractions just the way they are? No, because I need common
Denominators.
What is the least common denominator out of these two? 2. That means I need to make both of these into 2. It's okay, both of these into 2. Does anyone know what I have to do to this fraction to make
Times
it have
it by
a denominator?
2.
Okay. 4 over 2. Ready, guys? Some of you are already starting to get upset at me, or like you're starting to get, no, wait, what does he say? What's 2 divided by 1?
2.
4 divided by 2?
2.
Same number?
Yes.
Yeah.
Okay, and I'm not going to mess with 1/2. Okay, can I add these as just like they are?
Yes, 5.5.
Or sorry, 5 halves, or 5 over 2. Mr. A, why'd you do that? There's an easier way. Right? Isn't there an easier way?
Yes.
Okay, I'm not debating whether it's easier or not. I think the other way is easier. Guys, I agree with you. Do you or did you understand what I did here? I'm not saying you have to do it, but did you understand it? Kinda? Sorta? A lot? Okay,
Maybe.
You're in the spectrum. So now, let's do it your way. And it's okay if you do the problems that way. I'm okay with this. You just at least should be able to follow me here. Alright, so do you guys remember that? 2 times 2
Plus 1.
plus 1. Okay, so what's 2 times 2?
5.
4 plus 1. That's okay.
Sorry.
Mr. A, I know like. Okay.
I 50-50.
I never really memorized it that way. Is that okay? Like the second way?
You have it memorized?
No, I
That's
just
okay.
do the first way.
That's fine with me.
Okay.
And again, people might say, you know what, you're going the long way. Here's a cool way, easy way. Sometimes. You'll see when I give you a problem, I don't like this way anymore. This way is better. I'll get to that, just not yet. Okay, yes, William, go ahead.
Can I go get some water?
Yes. Okay, let's do one example together, and I'll give you one by yourself just to make sure you guys are getting this. Okay. Let's go with -3 and 4/11. Okay. How do I change this? How do I change this into an improper fraction? Or what I'm asking for, how do I change this into the form A over B? So what do I do? Yeah.
You could do 3 times 11 plus 4.
Okay, so what's 11 times 3?
33.
33 plus 4?
37.
37, and then you just keep the same denominator, which is 11, but do not forget,
Negative.
it's got to be negative. If it started off as a negative number, it's still a negative number. It doesn't just magically turn into a positive, so don't forget that sign or it's partly wrong. Okay, you guys get that? It's pretty simple. Okay, go ahead and listen carefully on the bottom of page 3. So look in your textbook, bottom of page 3. I want you to do, at the very bottom, number 9.
Do we do that on our homework page?
You do it on your notes page. Because if you get it right, great, you can move on. If you get it wrong, you can erase it and mark it out.
So which number?
Number 9 on the bottom of page 3. Number 9 on the bottom of page 3. And write the answer down, please, so we know what it is. Yeah, I'll get you, Drew, to give me the answer.
You already did it.
Number 9?
Oh, I haven't even looked at it.
No, I haven't done it yet, no. I'll let you guys, I'm just writing it down.
I thought you did.
Okay. Drew, tell me what you did again on this
3
one.
times 3 plus 2.
Yeah, 3 times 15 plus 2. All right, what's 3 times 15, everyone?
40.
Plus 2
47.
over
3.
3. Positive or negative?
Positive.
Yeah, what's positive? It stays positive. Okay.
That's
What is
pretty
the
easy.
That's good. Hear that? Someone in the other class, they boldly asked me, Mr. A, I did that way, I get it, but you can't do it the other way you said. I was like, wait. Okay. Let me just do it real quick. Is this 15 plus 2/3? Just agree or disagree. If you say this, then I can go back to it. But is that same thing?
Yes.
15
Okay,
over
15 over 1. What's the common denominator? 3. So I multiply this by 3 over 3. I get 45 over 3. It's a sloppy over 3. Plus 2/3. 45 plus 2. 47 over 3. Same answer. And in this case, yes, it was quicker, but you need to know this. And by the way, do you see where I got that 3 times 15?
Yes.
Right there. Plus the 2. Got the same answer. They're the same answer, different process. You should understand both. Yes, sir.
On homework, if there's some tonight that are mental, do we have to show
No.
up?
You can, some of these you can do mentally. Hopefully you get them right. Okay, we're good with that. Last type, writing, fractions.
Is this like a whole nother sheet?
No. This is just your next section. So if you have a space on your paper, or if you want to turn around.
Part 3.
No, not part 3. This is the end of part 2.
Gotcha.
And mixed numbers. And I hope, again, this is review. As decimals. So we can write numbers as fractions, but can we write them as decimals? Of course we can. Guys, let me give you a hint. It's kind of humorous, but I hope not in this class. I give you your homework assignment in just a few minutes, and then you're like, all right, Mr. A, what do I do? And then I'm like, did you read your instructions? Oh, don't ask me what to do until you read the instructions first. Then if you're like, I don't get it, please let me know. Does that make sense? Don't just look at the first one and say, I don't know what to do. Did you read the instructions? No. Oh. Because I think you guys can do it. And if you still don't understand it, please let me know. Okay, writing fractions and mixed numbers as decimals. Let's start off with the fraction -5/11. People get scared with those negatives because they're like, okay, I'm not really sure what to do, just ignore it. Your answer at the end should be a negative number, right? Because it started off as negative, it should end up negative. But do you guys remember how to turn 5/11 into a decimal? What do you do?
No.
Okay, what do you do, Darius? Do you know? Okay, what do you do, Michelle?
We divide.
Yeah, you just divide. You do 5 divided by 11. Which number always goes in that box? I call it the box. So in the box.
The lower number.
The top number.
Top number. Whether it's big or small, that's okay. Because you know what? People are going to say, Mr. A, what if those were switched? Well, then the top number goes in the box and the bottom number goes outside the box always. Okay, you know 11 is not going to go into 5, so I'm going to add a decimal point. And I tend to write 3 zeros after. You may or may not need that. May not. May need more, but I'd start out with 3. Don't forget to line up your decimal places. 11 goes into 5 0 times. 11 goes into 50. 4 times, that's 44. Then you subtract, you get your 6, bring down your 0. I want to work slower here because we struggled with this on those, on that diagnostic. Did you miss? Did you that pre-test you took at the very beginning? Some of you missed these. You went too fast or didn't know what to do, so I just want to make sure you're good. Now 11 goes into 60. 5 times, that's 55.
Is it 0.45 repeating?
It's 0.45 repeating.
0.45 repeating.
Okay.
0.454 repeating.
Okay.
Same thing.
Yeah, I got a lot of answers. One of those answers was correct. The other ones are incorrect because it has to be specific.
It's your boy.
Okay, 0.45 repeating with the negative sign. Yes. Okay, listen carefully. Okay, the reason it's not negative 0.454 is because that would be 0.454454454, and that would mean you'd have 2 4s together, right? Is that what we're saying in this answer? No. So just make sure you get it right. And that's okay, it happens. All right. Last problem I'll do with you, and then I'll let you get your homework started. It's going to be 4 and 3/8. So this is a mixed number. Now, this is where I appreciate understanding what numbers are. How many of you would do this? If you want to change this into a decimal, you would do 8 times 4 plus 3, which is 35 over 8. 35 over 8. And you would just divide those out. How many would do that?
I would, yeah.
Okay, I don't want to do that because I want to make the division easier. Okay, how do I do that? I need to remember, here's my thought bubble, that 4 and 3/8 is really 4 plus 3/8. So I already know part of my decimal answer. The decimal answer is going to be 4 point something. Right? Isn't this the whole number? Shouldn't it go right there then? I'm not going to do this division. I'm going to do this division.
Oh.
Because I understand that this is...
Ooh, got me there.
The thing is, guys, when you understand numbers, you can make your life easier. And you can do it this way. You don't have to do it the way I'm doing it, but you can. All right, what's 3/8 as a division problem? 3 divided by 8. Okay? I have my 3 zeros. The numbers are nice and easy for me. So 8 doesn't go into 3, but 8 goes into 30. 3 times, that's 24, 6, 0, 7, 56, 4, 0, 5 exactly. So what's my answer? 4.375. You're done. And it's positive or negative?
Positive.
Positive.
Positive,
Oh,
Darius.
sorry, I was looking at the other.
That's okay. That's
On
all
my
right.
paper, not on the board.
You guys okay with that?
Yep.
You can do it this way. I'm okay with that, but you can also do it that way. Listen carefully. We do have some time left for you to do your homework. Use it wisely. I had one student in the last class sit there the whole time not doing anything. I was like, okay, but I'll give you a little help. I'm going to give you help.
Wilson, Joey.
Wilson, Joey, I'm waiting. I'll give your homework so you're done. If you are sitting there without doing anything, I'll give you more homework. Because you're telling me, Mr. Ray, this is so easy, I don't even need to do it during class. I'll just get it done at home. Let me give you some more. Please, for your sake. Let's start working. Numbers 10 through 38 even. Okay, that means this. 10, 12, 14, 16, all the way to 38.
We have
19 problems.
Oh, sorry.
It's okay, I don't mind. And number 55, that's one word problem, and that's going to be on pages 1 and 2, because we're still finishing up that first lesson. We're still back on 1 and 2.
Oh,
Okay.
55 is on the other page.
Yes, exactly. So that's why I had to put number 2.
Where's number 30?
Yep. You can't, yeah, if you want to write the assignment on there, fine.
What's today, Thursday?
Okay.
Bye-bye, Swivl. Bye-bye. Okay, Swivl doesn't want to say bye.